everyone, welcome to the course Structure Analysis. I am Dr.S.Pachaiappan, Assistant Professor, Department of Civil Engineering, Aditya University. So today we are at the 23rd lecture, which is ILD for bending moment calculation. So far we have seen the concept of ILD, how to calculate the reaction force by using the ILD. For example, RA, RB, both UDL and point load we are discussed. And then we are discussed how to calculate the shear force by using the concept of ILD. Now today's lecture we are going to discuss how to calculate the bending moment by using the concept of ILD. So today is the 23rd lecture. The title of the lecture is ILD for bending moment. At the end of the lecture, the student can able to apply the concept of ILD for the calculation of bending moment. So for a bending moment, I am considering a simply supported beam carries a 1 unit force which is located x distance from the support A. Okay, and at center point C, I am going to calculate the bending moment. From the left support to and point C, the linear distance is A, and then the right support to the section XX or point C, the distance is B. So we know the value RA is nothing but L minus X by L, and then RB is X by L from the previous lecture. Now I am going to take the moment at the point C. If I take the moment at the point C, then what are the things are there? MC is equal to RA multiplied by the linear distance is A, then minus 1 multiplied by A minus X. Why A minus X? Because this distance is A minus X. Total distance up to C is A minus X will give you the remaining distance. So this is what written here, RA multiplied by A minus 1 into A minus X. Now I am substituting RA value is L minus X. So here it is the RA value I am substituting. So it will become L minus X by L multiplied by A and then minus of A minus X. Okay. So just multiply by this A inside the bracket. So we will be getting AL minus AX by L minus A minus X. Now multiplying this L inside the bracket, I will be getting AL minus AX minus AL plus XL. Now you see the AL will be get cancelled. I will be having minus of AX and then XL. So when I am putting X is equal to A, what does mean? Initially the 1 unit force is acting distance from the support A. If you put X is equal to A, then the load exactly acting at the point C, where we are going to calculate the bending moment now. Okay. So I am putting X is equal to A. So you see here instead of X I am going to put A. So A multiplied by A, it become A square. So AL minus A square by L. Okay. So in this A I am commonly taking outside. So it will become L minus A, and this L minus A is nothing but B. Okay. L minus A, why it is become B, I will explain. So this is A and this is B, total distance is L. So total distance L minus A, the distance is B. So this is L minus A, which is B. So that's what substituting here. So instead of L minus A, if you put B, then it will become AB by L. So moment at point C, when the load is acting exactly at the point C, the moment is nothing but AB by L. We calculated moment at point C is AB by L. Just cross verify that. What I am going to do, I am taking moment at C from, I have calculated from RA value. Now I am going to go from right to left to cross verify that value. So taking moment at this location, so RA multiplied by the linear distance A. Why it is linear distance A? Once you can see here, this is the simply supported beam, okay, and this is our X section, this is our A distance, okay. Now what I am doing, RA is acting here, RA multiplied by the linear distance A, okay, taking moment at the point C. This is the point C. So substituted the value of RA and then multiplied the linear distance A. So this is for when X is equal to A. So putting x is equal to a, I will be getting L minus a by L multiplied by a. L minus a is nothing but b, ba by L. So I am getting ab by L once again. So this is to cross verify. Okay. So this is the value of MC. And if you draw the bending moment diagram, since it is a simply supported beam, we have taken bending moment at the right support 0, bending moment at the left support 0, only we have the maximum bending moment at point C, which we are calculated, that is AB by L. Now how to apply this in the real problem? It's very simple. We need to draw this triangle. This triangle is nothing but ILD for bending moment. So we'll take a real example and then we'll apply this concept. Now you can see I have taken the simply supported beam, in that the first point load is acting 200 kilonewton. After 2 meter distance, another concentrator load of 80 kilonewton is acting. Then what I need to do? I need to draw the ILD diagram for the bending moment, which is this triangle. Okay, drawn. After that, I need to drop the ordinates, that I have done here. So, but where I am going to keep the load? That is a confusion, right? So, what we have to do, let's say I am drawing these loads here. We have 200 kilonewton and then we have 80 kilonewton. In between, we have 2 meters distance. So, you see, this is called as the head of the load and this point is called as the tail of the load. So, it's very simple. First, I am going to keep at my C section, at point C, first I am going to keep the head of the load and then now I am dropping the ordinate. So, this is ordinate 1, ordinate 2. Next, what I will do, by using a similar triangle, I am going to calculate what is x1. So, only x1 is there. This is nothing but 15 by 4 is nothing but AB by L. Okay. So, let's do it here. A is 6 meters, B is 10 meters, AB by L is 16 meters. Okay. This is we got 15 by 4, okay, 60 by 16. So, it's a 50 by 4 and then by using a similar triangle, 15 by 4 divided by 10 is for this larger triangle. I don't know the x1 value. So, x1 divided by this linear distance is 8 meters. So, I got the value of x1. Now, what I have to do, MC is nothing but 200. This load multiplied by the ordinate is 15 by 4, which is positive, plus 80 multiplied by the corresponding ordinate. Recently we got, that is, so 80 multiplied by x1 value is 3. Okay. So 200 multiplied by 15 by 4 plus 80 multiplied by the x1 value we got, which is 3. So, by similar triangle, we are computed that value and then we are calculated moment at point C. In addition to that, for better understanding, we will take another example. You see here, find the maximum positive shear force and then negative shear force and then maximum bending moment at section 3.5 meters from the left support. So, this is how the problem will be asked in the examination. Okay. So, it is traveling in the simple girder of span 6 meters. A single point road rolls across the girder. So, they given the 100 kilonewton load is traveling from the support A to B. So, they told us to calculate the maximum positive bending moment and then shear force. Since they first asked the shear force, I need to draw the ILD for shear force. So, this is the ILD for shear force. Then what we have to do? We need to drop the ordinate, but here only one load is there. Exactly at center we are keeping that. We have calculated the value of A by L and then we have calculated the value of B by L. So, A is 3.5 and then B is 2.5 meters. For the maximum shear force, we are calculating 100 multiplied by that corresponding ordinate. This is the positive value. For the negative shear force, the same ordinate we need to keep it in the negative direction. That's it. Because you see, the B by L value is 2.5 by 6, okay, which is nothing but 5 by 12. We can say that is 5 by 12. Okay, this is positive. In the opposite direction, what we are having? We have A by L, which is 7 by 12. But this is in the negative ordinate. That's why we are substituting the negative ordinate, we got the negative shear force. So it's very clear what we have to do. We need to take the ILD for the shear force diagram. Since only single concentrated load is given, we need to keep it on the point C and draw the ILD for a shear force diagram, drop the ordinate, either it's x1 or x2, calculate it, load multiplied by their corresponding ordinate is going to give you the shear force. And then in the shear force, we have 2 points, one is B by L, another one is A by L. B by L is in a positive direction and minus A by L in the negative direction. That's why we are substituting. A by L is nothing but this 7 by 12, we substituted the negative value. So we got the maximum positive shear force, also the maximum negative shear force. So another example, 100 kilonewton. So just I am drawing the diagram. And similar way, we need to compute the bending moment also. The same problem only. Now I am computing the bending moment. So 100 kilonewton is kept 3.5 meters from the left support, which is given in the problem. This is ILD for bending moment. Okay. So we know this ordinate already we are calculated, which is AB by L. So A is 3.5. B is 2.5 by L is 6 meters. So AB by L I am getting 35 by 24. So actually it is in a fractions. I never want to write 0.00 something. That's why it's 35.24. Okay. So what is the bending moment? The load multiplied by the corresponding ordinate, maximum positive bending moment. Okay. Now absolute maximum bending moment, what we have to do? We need to exactly keep the load at center. So we know already, if the simply supported beam is there, it is a symmetric. Maximum bending moment occurs only when you keep the load at the center. If it is somewhat away from the center also, we will get some bending moment value, but that is not a maximum. So this 145.83 kilonewton, we got it when the load is kept at 3.5 meter from the left support. So we got the value 145.383 kilonewton meter, and this 100 kilonewton is kept at center. Load is kept at center. So you can able to see, so when we are keeping the load at center, we are getting 150 kilonewton meter. So that would be the maximum value. If you keep the load 100 kilonewton anywhere across the beam, nowhere we are going to get the maximum value than this 150 kilonewton meter. So 150 kilonewton meter is the maximum value that we will get only at the center when we are keeping the load at the center. That's why it is called as absolute bending moment. In this case, the 145.83 is a bending moment for a particular location. So from this, you can understand how to apply the concept of ILD for a bending moment and then calculating the bending moment value of the simply supported beam. Okay. So thank you for watching this lecture. Thank you.